this video, we're going to talk about section 3.3, properties of determinants, and we're going to start off with number one. Number one asks us in part A to find the determinant of A. Part B is going to ask us to find the determinant of B. Part C is going to ask us to find A times B, and part D is going to ask us to find the determinant of A times B. And we're going to see if we can recognize a property here that's going to be true. And for number one, it tells us that matrix A is equal to -2, 1, 4, -2, and matrix B is equal to 1, 1, 0, -1. So the determinant of matrix A for part A here is going to be equal to that, which is equal to that, which is 0. So -2 times -2 is 4. 1 times 4 is 4. 4 minus 4 is 0. For part B, we have determinant of 1, 1, 0, -1 is 1 times -1 is -1, minus 1 times 0 is 0, is a -1. Now for C, we need to go back to our rules for matrix multiplication. AB is going to be row 1, column 1 to give me row 1, column 1 entry. That's -2 plus 0. Now row 1, column 2 is -2 minus 1. Row 2, column 1 is 4 plus 0. And row 2, column 2 is 4 plus 2. So that gives me a -2, -3, 4, 6. And the determinant of that, because row 2 is -2 times row 1, is going to be 0. And what they want you to see there is that the determinant of AB was equal to the determinant of A times the determinant of B. And that was 0 times -1 was still 0. So we'll use that property here coming up in a few more problems, but let's look at another example of this where they give us a matrix A and B and ask us to complete all 4 pieces here. So I'm going to erase this part, but leave instructions A through D up there. For problem number 3, we have A is equal to -1, 2, 1, 1, 0, 1, 0, 1, 0, and B is equal to -1, 0, 0, 0, 2, 0, 0, 0, 3. So for part A, the determinant of A is going to be the determinant of -1, 2, 1, 1, 0, 1, 2, 1, 0. I like row 3 the best down there because it has the most zeros and ones for me to use the most zeros. So 0 times the determinant of 2, 1, 0, 1 minus 1 times the determinant of negative 1, 1, 1, 1 plus 0 times the determinant of negative 1, 2, 1, 0. So I don't need to find that determinant or that determinant. I just need negative 1 times 1 is negative 1. 1 times 1 is 1. That difference there is negative 2. So negative 1 times negative 2 is 2. Part B asks me to find the determinant of B, which is going to be the determinant of negative 1, 0, 0, 0, 2, 0, 0, 0, 3. This is already a lower triangular matrix, so my answer is negative 1 times 2 times 3 is a negative 6. So, I'm sorry, I said lower triangular, I meant upper triangular. There's zeros in the, well, there's zeros everywhere. It was both upper and lower triangular. It just had numbers along the main diagonal, which makes it real easy to see what I'm talking about, that I just multiply that main diagonal to get my determinant there. So now we're going to take C. Part C is matrix A times matrix B is, and then that is going to be row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 1, row 2, column, I'm sorry, row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, and row 3, column 3. All right, so this is yep. D is the determinant of negative 1, 4, 3, negative 1, 0, 3, 0, 2, 0. Let's just do that down here. Give myself more space. All right, so I can go ahead and expand on this bottom row here using minors and cofactors. So that's 0 minus 2 times negative 1, 3, negative 1, 3. It should be a 1, not a negative 1. A B, negative 1 times negative 1 is a positive 1. And plus 0. So that's negative 2 times 1 times 3 is 3. Minus 3 times negative 1 is a negative 3. So negative 2 times 6 is a negative 12. And we just want to show that a B determinant is the determinant of A times the determinant of B. So is let's see, we had a determinant of 2 and a determinant of -6, which is -12, and these two match. Move ahead to number 9, and the instructions there ask us to use property 3, but like I said, when we talked about property 3 for determinants, if we had C times everything in A, here I'll write out what it says here in the problem, to use the fact that if I have C determinant of A, that's C to the N times the determinant of A, since A is N by N in nature, and you're pulling a C out of each row or column here. So that's number 9. And we want A is equal to -369, 6, 9, 12, 9, 12, 15. So we see everything's divisible by 3. So determinant of A is going to be equal to 3 to the third is going to be 27 when we pull it out. Determinant of -1, 2, 3, 2, 3, 4, 3, 4, 5. So let's get to work with that. And I'm just going to use some elementary row operations here to change this a little bit. So I want 2 row 2 plus row 3 to produce a new row 3, and 2 row 1 plus row 2 to produce a new row 2, and 3 row 1 plus row 3 to produce a new row 3. I want to get zeros beneath that -1. So this is 27 times -1, 2, 3, 0, 7, 10, 0, 10. This is 14. Then I want to have let's pull out this 2, so that's 54. Is I mean, I can go at it from here now that I've got the zeros there. So this is 54 times -1 times the determinant of 7, 10, 5, 7. And then this is going to be -0 and +0 there. So this is -54 times 49 minus 50 is 54 times a -1. Sorry, -54 times a -1 is a +54. So we'll go with that. Move on now to number 15. 15 is a multi-part problem and asks us to, in A, find the determinant of A, in B, find the determinant of B, in C, find A plus B, and in D, find the determinant of A plus B And we're interested in showing that the determinant of A plus B is not equal to the determinant of A plus the determinant of B. That doesn't work. So, not that they can't be equal sometimes, like if one of those determinants is 0, or if one of those matrices is 0, then clearly that would work in a trivial case, but it should not work all the time. So A is -1, 1, 2, 0, and B is 1, -1, -2, 0. So A is the determinant of A is 0 minus 2 is -2. The determinant of B here for part B is 0 minus 2 is -2. Part C, matrix A plus matrix B is 0, 0, 0, 0. And that is D. The determinant of A plus B is clearly going to be 0 because it has all zeros in it. So number 23 asks us to classify the matrix as being singular or non-singular based off of its determinant. If it has a 0 determinant, then it's going to be singular. If it has a non-zero determinant, it'll be non-singular. So A equals 1, 0, -8, 2, 0, 8, -1, 10, 0, 0, 0, 1, 0, 0, 0, 2. So this will be singular. If I find determinant of A, it has to be 0 because our 4 is equal to a negative, or is equal to 2 times our 3. If I would do elementary row operations on the determinant of A, I would get a row of zeros in the bottom there, and that would give me a 0 determinant. That means that this is a singular matrix, and that means that it has no inverse. Okay, let's look now at number 29. And we want to find the determinant of the inverse matrix by using the formula that the determinant of the inverse matrix is equal to 1 over the determinant of the original matrix, or we can write it this way. So if we find the determinant of the original matrix in 29, we can just find the reciprocal of that to find the determinant of its inverse. Matrix A is 1, 0, -1, 3, 1, 0, 3, -2, 2, 0, 2, -1, 1, -3, 1, 2. So I would like to, if possible, make myself get a triangular matrix here with some elementary row operations. So negative row 1 plus row 2 to produce a new row 2, -2 row 1 plus row 3 to produce a new row 3, and negative row 1 plus row 4 to produce a new row 4. It's going to give me 1, 0, -1, 3, 0, 0, 4, -5, 0, 0, 4, and then that's -6, that's -7. And then we have 0, -3, 2, and -1. So I'm going to swap I guess I should do the determinants before I do this. That's fine to have done that piece because that doesn't change the determinant at all. But let's go ahead and write the determinant of A, which was the determinant of this is equal to the determinant of this because of those row operations that I just did. All right, now I want to make a couple of row swaps to get this -3 to be up there and get the zeros beneath it. So again, I'm only going to row swap adjacent rows. So this is going to be, this first row swap gives me this. And the second row swap changes it back to a positive and is 1, 0, -1, 3, 0, -3, 2, -1, 0, 0, 4, -5, 0, 0, 0, 0, 4, -7. And I'm going to add the opposite of row 3 to row 4 to produce a new row 4. And that's 1, 0, -1, 3, 0, 3, 2, -1, 0, 0, 4, -5, 0, 0, 0, and then -2. So my determinant is going to be equal to 1 times 3 times 4 times -2. And this is a -3, -3. So that is a positive 24 for my determinant of A. So my determinant of A inverse is 1 over 24. Let me go ahead and prove to you that that is true using some technology here. So if I would go ahead and find A inverse with my calculator, I'd get that it's equal to -1/8, -5/8, 7/8, 0, 5/12, 5/12, -1/4, -1/3, 3/8, 7/8, -5/8, 0, 1/2, 1/2, 1/2, 0. So I would expand on this last column over here to find its determinant, and would find that the determinant of A is equal to, so this is plus, minus, plus, minus, plus, minus, plus, minus. So that's going to be a positive 1/3 times the determinant of, and then 5/12, 5/12, -1/4, 3/8, 7/8, -5/8, 1/2, 1/2, 1/2. And I would like to pull some stuff out of there to make my life easier. So I'm going to pull a 12th out of row 1. And an 1/8 out of row 2, and a 1/2 out of row 3. And that gives me 5, 5, -3, 3, 7, -5, and 1, 1, 1. I'm going to expand on that row of 1s after I do that. That gives me 1 over 36 times 16. That is 216, and 36 is 576. For my denominator, no, that is what did I write 12ths there? That's fine. And then expand on that one. So let me just follow my steps that I had here so I don't get myself in trouble by doing something different. So if I start off with this is, like I said, -1/3 times determinant of -1/8, -5/8, 7/8. Yeah, I don't know why I was writing 12ths down. 3/8, 7/8, and -5/8. And then 1/2, 1/2, and -1/2. Then I'm going to make this -1/3 times -1/8 times 1/8 times 1/2 times the determinant of 1, 5, -7, 3, 7, -5, and 1, 1, -1. So that would be 1 over 384 times this determinant, which is, I'm going to expand on this bottom row here. which is going to be 1 times the determinant of 5, negative 7, 7, negative 5, and then minus 1 times the determinant of 1, negative 7, 3, negative 5, and then plus that negative 1, so minus, and then the determinant of 1, 5, 3, 7. So that's 1 over 384 times, then this one is negative 25 plus 49 minus, and then this one is negative 5 plus 21. And then this one is minus 7 minus 15. So that's 1 over 384 times, that's going to be 24 minus 16 plus 8 is 16 over 384, which is going to be 4, which is equal to 1 over 24 when we reduce that fraction, which is exactly what we got with our property. Let's go ahead and look at number 33 now. And that's a system of equations. And we want to find if that system of equations has a unique solution or not. So 33, this is kind of similar to asking if this matrix, which is formed from this system of equations, is singular or not. So if it's singular, it doesn't have a solution, or it could potentially have infinitely many solutions in a parametric form, but it's not going to have a unique solution. So we're going to change this into a determinant. 1, negative 1, 1, 2, negative 1, 1, 3, negative 2, 2, and through some matrix operation or some determinant row operations there, I can say that this is negative 2 row 1 plus row 2 to produce a new row 2, and negative 3 row 1 plus row 3 to produce a new row 3. It's going to give me 1, negative 1, 1, 0, 1, negative 1, and 0, 1, negative 1. And I see that row 2 and row 3 equal each other, so that determinant is 0. My row 2 equals my row 3 there. So no unique solution. There's either no solution or infinitely many solutions, but not a unique solution. Let's move on to number 37. And it asks us about singular matrices here. So 37 has the matrix A, which is equal to K minus 1, 3, 2, K minus 2. And it says to find a K so that A is singular, so that the determinant is 0. is what we want. So k minus 1, 3, 2, k minus 2 equals 0. So that's k minus 1 times k minus 2 minus 6 needs to be equal to 0. That's k squared minus 2k minus k plus 2 plus 6 equals 0. K squared minus 3k plus 8. Sorry, plus, it's a minus 4 equals 0. So that's k plus 1 times k minus 4 equals 0. K plus 1 equals 0, or k minus 4 equals 0. K equals -1, or k equals 4. Moving on to number 39, same instructions, trying to find under what conditions this determinant or this matrix would be singular. So we have 1, 0, 3 to -1, 0 for 2k. So let's go ahead and I think I expanded this on row 1 here and said 1 times the determinant, -1, 0, 2k, minus 0 times the determinant of 2, 0, 4k, plus 3 times the determinant of 2, -1, 4, 2. That is 0. So this is 1 times -k minus 0 plus 3 times 4 minus a -4 is 4 plus 4. That's a -k plus 3 times 8 equals 0, equals 0, equals 0. So -k plus 24 equals 0. -k equals a -24, and k equals 24 will make this singular. Let's move on to number 47, which is a multi-part. Part A of this problem asks me to find the determinant of A transpose. A transpose of a matrix is switching the rows and the columns. Part B asks me to find the determinant of A squared. Part C asks me to find determinant of A times A transpose. Part D asks me to find determinant of 2A, and part E asks me to find the determinant of A inverse. So 47 is A equals 205, 4, -1, 6, 3, 2, 1. And the transpose of that matrix is going to be 2, 4, 3, 0, -1, 2, 5, 6, 1. So the determinant of that transpose is going to be equal to and let's expand on this column here, which we can use rows or columns, but let's take advantage of that 0. So 2 times -1261 minus 0 plus 5 times 4, 3, negative 1, 2. That's going to be 2 times negative 1 minus 12 plus 5 times 8 plus 3 is 2 times negative 13 plus 5 times 11 is negative 26 plus 55 is 29. And then, so that was A. B asked me to find A squared. So this is determinant of A times A. So that should be this times itself. So that should be that determinant squared. And that was equal to, really that doesn't make any difference with the transpose, but I'll show you that it doesn't make any difference here, that this is 2 times negative 1,621 minus 0 plus 5 times 4 negative 131 is 2 times negative 1 minus 12 plus 5 times 4 plus 3. So that is squared. That is 2 times negative 13 is negative 26. 5 times 12 is check this. 2 negative 1,621, and then 4 negative 1 3. This is a 2, so that is an 8. That's 55. So that is 29 squared, which is 232. No, 841. And then, so the determinant of A is 29. We've found that here, that was what was inside there that was being squared. So C is equal to the determinant of A transpose, which is determinant of A was 205 for negative 1,6,321 times the determinant of, so when I have determinant of A times B, it's determinant of A times determinant of B, and we already did this where we transposed it and it didn't make any difference in the determinant. So that is equal to 29 squared is also 841. D is determinant of 2A is 2 times the determinant of A is 2 times 29 is 2 cubed times 29, because we're doing determinants and it's a 3 by 3. So that's 8 times 29 is 232. And E is determinant of A inverse. So 1 over the determinant of A is 1 over 29. That's going to be it for this video, and we'll come back next time and we will talk about 4.1, which is vectors in Rn. So I'll see you for the next video.